All right, let's dive right in. We live in a world that's just swimming in data. So how do we make any sense of it? How do we find out what's actually true? Well, today we're going to explore the two giant pillars that hold up all of modern data science, the core ideas of statistics and the awesome power of the programming language, Python. Let's get to it.
You know, at its heart, data science is just a fancy name for something we humans do naturally. We are hardwired to look for patterns. We just have this deep-seated curiosity to figure out why things happen, to discover truths that are hiding in plain sight, and just to make sense of this big, complicated world. And it all kicks off with one fundamental idea.
So let's start right there. Before we even think about writing code or doing any complex math, we've got to ask the big, foundational question. What are we even talking about when we say the word statistics?
At its most basic level, statistics is the science of how we handle information. Think of it as a repeatable process, a recipe. It takes you from collecting all this raw data to organizing it and finally analyzing it to get real, meaningful answers. This right here, this is our first pillar.
But why do we even need a formal process for this? Well, it's not just for researchers and lab coats. We use statistics to feed that curiosity, to give us a method for hunting down patterns. And, this is the big one, it gives us a way to find actual evidence to see if our gut feelings are right or if we're totally wrong.
You know, maybe the best way to think about statistics is as the language of data. It gives us the grammar, the rules, and the vocabulary to understand the stories that are buried inside all those numbers. And just like any good story, the first thing you need to do is get to know the main character, which means finding the center of your data. And that brings us to a concept called central tendency. Before we look at how data is spread out or how different numbers might be related, we first have to find its anchor point. It's like finding the center of gravity for your data set. And it turns out there are a few different ways to do that.
First up is the one you definitely remember from school, the mean. It's just a good old numerical average. You add everything up, divide by how many you have, and boom. But while it's super common, it's also a bit sensitive. A single really high or really low number can pull the whole average way off.
Next up, we have the median. This one's pretty cool. If you line up all your numbers from smallest to largest, the median is the one sitting smack dab in the middle. The best part? It doesn't get thrown off by those extreme values, which makes it perfect for things like home prices or salaries.
And finally, we've got the mode. This one's the easiest of all. It's simply the value that shows up most often. It's the most popular choice in the group. Think of it like looking at a rack of t-shirts and seeing which size is the most common. That's the mode. So the big takeaway here is that these aren't interchangeable. It's all about picking the right tool for the job. You'd use the mean for something like an average salary, the median for a satisfaction survey, and the mode to figure out which brand people prefer. It all depends on your data and the question you're trying to answer. Okay, so finding the center of one set of numbers is great. But where things get really exciting, where the magic starts to happen, is when we begin to look for connections between different things. How does one variable affect another? So let's take a look at a super simple, real-world example. Say we're tracking the temperature outside and how many customers come into a shop. Now, just by glancing at these 5 little data points, you can probably spot a bit of a pattern. But what if you had 5 times years of this data, millions of data points? There's no way you could just eyeball that. And that is exactly where our second pillar comes crashing in. Because understanding the language of data is one thing, but being able to speak it fluently across millions or even billions of data points, for that, you need a serious power tool, and that tool is Python. So why Python? I mean, there are tons of programming languages out there. Well, it's because Python is this amazing mix of being incredibly powerful, but also surprisingly easy to get started with. It runs pretty much everywhere, its code reads almost like plain English, and you can use it for just about anything. It's the perfect sidekick for a data scientist. Now, this really gets to the heart of why Python is so flexible. A language like C++ is kind of rigid. Its data containers have a fixed size and can only hold one type of thing. A Python list, on the other hand, is like a magic expanding backpack. It can grow as big as you need, and you can toss in numbers, text, whatever you want, which is absolutely essential when you're dealing with messy, unpredictable, real-world data. Okay, this is the moment. This is where our two pillars finally come together. We can take the powerful ideas from the language of statistics and combine them with the raw muscle of Python to find insights that would be completely impossible to spot by hand. What this means is we can basically teach the computer how to do statistics for us. So that mean we talked about a minute ago?
We can write a little recipe in Python called a function that knows exactly how to calculate it. You just hand it a list of numbers, and it hands you back the average. Simple as that.
And this gives us an incredibly powerful workflow. We can go back to our temperature versus customers data, plug it into Python, and then just tell the computer to analyze it. It can instantly create a chart for us to see the relationship, and even better, it can calculate the exact strength of that relationship.
And bam, Python does all the hard work and spits out a single number. This is called a correlation coefficient, or just R for short. In this case, we get a value of positive 0.96. Now, a number that close to positive 1 is huge. It's basically screaming at us that there is a very, very strong positive relationship here. In plain English, as the temperature goes up, the number of customers tends to go up too.
But, and this is a huge but, there is a giant, flashing red warning sign that comes with this discovery. Every data scientist has this phrase burned into their brain. Correlation does not equal causation. Just because temperature and customers move together doesn't mean hot weather causes more customers. Maybe it's just that hot weather happens during summer vacation, and that's the real reason. It's maybe the most important rule in all of statistics.
So let's pull back and put all the pieces together. When you boil it all down, what are the key things you really need in your toolkit to start thinking and acting like a data scientist? It really just comes down to these three things. You need statistical thinking, that's the language that lets you ask smart questions. You need Python programming, that's your power tool to analyze massive amounts of data. And finally, the ingredient that powers everything else is just good old-fashioned curiosity. That drive to always be asking, why?
So there you have it, the two pillars. Statistics gives you the language, the map to understand the world. Python gives you the power, the vehicle to go explore it. These are the tools that let us find the secrets hidden in the data all around us. The only question left is, now that you know about them, what patterns are you going to uncover?